Knowing how indexes fit with Pandas data frames and series, we can now look at representing multi-dimensional data with hierarchical indexes. Let's motivate this with some stock data. Here's a data frame with some Apple, Cisco, and Microsoft stock trades taken over 3 days. The columns are the date, the closing price, the volume traded, and the ticker symbol on the stock. Notice the default index is an integer range. The rows are not sorted sensibly. There are repeated values in the date and symbol columns. We would prefer using a meaningful index that uniquely identifies each row. Individually, both the date and the symbol columns are inappropriate due to repetitions. The trick then is to use a tuple, symbol and date, to represent each record in the table uniquely. We use setIndex with an ordered list of column labels describing the new index. When we print stocks now, the index is no longer a range of integers. Instead, the index comprises 2 columns, symbol and date. Of course, the data frame is still unsorted. We print out and examine the new index. It is a multi-index or a hierarchical index composed of the entries from the original symbol and date columns. Notice when we print stock.index.name, the result is none. When we print stock.index.names, the result is the list symbol, date. We need to call sortIndex to sort the data frame. Again, we assign the output of sortIndex. This makes a new data frame in memory. Printing the sorted data frame shows the multi-index labels in a readable, ragged form with gaps where the symbols AAPL, CSCO, and MSFT would be repeated. Sorting a hierarchically indexed data frame is useful for indexing and slicing. For example, calling the .loc accessor with the tuple CSCO, 2016-10-04 extracts the 5th row of the sorted data frame. If we follow the tuple with a column name, say volume, we can extract a single element of the table. Calling the .loc accessor with the string AAPL alone slices on the outer index, returning all rows corresponding to AAPL trades. We can also extract a slice using a range of symbols. As an example, say CSCO, MSFT. This extracts the bottom 6 rows of the sorted data frame. Fancy indexing, or using lists in indexing, is also possible. We can slice the rows for AAPL and MSFT data on October the 5th, like this. And if we want only the close columns on those days, we do this instead. Fancy indexing also works on the inner index. Here, we pull the CSCO rows from October 5th and October 3rd in that order. There's a trick to slicing with hierarchical indexes. The tuple used for the index does not recognize slicing with colons natively. To force that to work, we need to use the Python built-in slice explicitly. For example, here we use the tuple slice none, slice 2016-10-03, 2016-10-04 to extract rows from all symbols for the dates October 3rd through 4th inclusive. It's a good idea to practice this. Try the exercises now to get used to multi-indexes and hierarchical indexing.